Today the next thing that I'm going to demonstrate is how to do a titration. So one of the things we're going to be doing in the lab this coming Wednesday is titratable acidity. And so I have an apple juice sample here, which is the same apple juice sample we used for pH measurement. And the directions call for adding 10 mils of sample to 90 mils of DI water. So I'm going to go ahead and transfer 10 mils over using a pipette. And so the pipette, this is a glass pipette, pipette aid that I'll put on the top. We'll suck it up by pushing down on this. And there's marks here that we'll go ahead and count. So and hopefully you guys have taken chemistry in high school, and you'll remember that we want to make sure that the meniscus of the sample, which is the curved down part, is on the measurement or line that we're looking for. So mine is at the top, which is 0, because this pipette holds 10 mils. So 10 mils, I'll go ahead and I'll push that down into the container. So we have already measured out 90 mils of DI water, and so I'm going to go ahead and put that in there as well. And then I'm going to go ahead and add our indicator, which is phenolphthalein. And I think somewhere between 2 and 3 drops is sufficient. We are going to be titrating this with sodium hydroxide, and so this is the container that contains the sodium hydroxide. Okay, so we've already gone ahead and added our sodium hydroxide, to our burette here. And you can see here we have a funnel up at the top so that it's easy, or so that we don't spill when we go ahead and fill it. Something to note here with the burette, it starts off at 0 and ends up at 50, so it's backwards compared to the pipette in terms of the numbering. And you do not need to fill it up to the top in order for you to take your reading and get started. So we're going to go ahead and read where the sample is now, and then when we're done with our titration, we'll read that number again, and we'll subtract them and know how many mils of solution we used. So these burettes can be hard to read because of the clear background, so if it's easier for you, go ahead and put up some sort of white sheet of paper. The other thing to note, you should be at eye level with it, so either move it down, have the tallest person in your group read maybe that initial reading, or you can also shift the burette down. So we can see here that we have 10. Each of these tick marks are worth a tenth, so 10.1, 2, 3, 4, 5, 6, and it's pretty much on the 6. So I will go ahead and record this down as 10.60 mils. Okay, so now we're ready to go ahead and do our titration. So as you remember, we had 10 mils of sample and 90 mils of DI water. If you've already read through your lab, you'll know what color this should form when we add sample to it. So we might start to see a pink color, and the color that we're looking for is a really faint pink color. And so we're going to try to get that, and then I'll show you what it looks like when you've over-titrated it as well too. I'll go ahead and change this. This is the stopcock, and when you move it, it eventually opens, you see. So initially, probably going to want to be pretty slow with the dripping of it in there. And you can go ahead and shake it. Alternatively, you can have a partner shake and one person be in charge of the burette. I'm going to make it. So patience is T. And we're going to go ahead and stop it here. You can see that it's turned a little pinkish hue. Depending upon your sample, some of you guys might end up doing orange juice, and so you're going to really want to watch for that color change. So well, let me take a measurement real quick so we have this down. So you go back up to the burette and take a look at it, and it is, oh, the camera's in my way, I can't see it now. It's 19.3, maybe 19.31. We'll call it 19.31. So it was originally at 4 something. Oh, 10.6. Sorry, I should have recorded it down. I didn't. 10.6, and now it's at 19.31. And so that is approximately 9-ish mils. And so let me show you what happens. We add too much. That color means you've over titrated, which means you'll get to do the titration over again. And we ask that you do it 3 times, the titration 3 times. So on this next titration that I do, I now know that it takes approximately 9 mils for the sample to be completely titrated. And so instead of doing, it very slowly drop by drop, I can go ahead and let 19 or 9, maybe 8 mils to be cautious go down, and then that last mil I can slowly add so that I don't over titrate. Okay, thank you.